The Ethereum Attestation Service has the potential to change the world. However, without some way to filter who can make the attestations and maybe some additional logic that gets executed on attestation, EAS is fairly powerless. And in this video, I'm going to show you what resolver contracts are and how they solve this problem. My name is Hakeem and I'm a Web3 engineer. My mission is to help you land your dream role in Web3. So let's begin. So in front of us here, we have the EAS website. On the EAS homepage, if you scroll down, you'll see this screen here that says, what will you build? And it has all these different potential applications, functionalities that you can build into your app or service. First, let's quickly recap what the Ethereum Attestation Service, or EAS, is. EAS is a infrastructure level system that allows any address or potentially any address to make an attestation or a claim against another address on the Ethereum blockchain. So these examples here are showing different example applications that you can build using this infrastructure. If we look at any one of these examples, let's look at voting systems. Anybody can vote right now. But what if you're under 18 or you're not allowed to vote or you've already voted? How do you prevent somebody who's not allowed to perform a certain action from doing that attestation? Now, let's just go over what attestations are. An attestation is a confirmation of a given event happening on the blockchain or off chain. And this applies to any one of these examples: ticketing, social networks. So for any of these examples, you want to filter out who can make an attestation, who can make a claim, not just anybody. And maybe you want some additional logic. So in this video, we're going to make a resolver contract that does a whitelist essentially. So if we head over to use case examples, and let's go into tutorials using resolver contracts. Let's quickly skim through some examples to see how resolver contracts can become so powerful. So it can act as a hook for a schema to ensure that attestations conform to specific rules or any smart contract logic before they can be completed. So they are like a check to see if the attestation is legitimate. So you could allow a whitelist of users that can create attestations, which is what we're going to be doing a basic version of. Or we can mint NFTs when specific conditions are met. Again, this could be any piece of logic you want. In another resolver, we have one that expects Ethereum to be sent along with the attestation. So in the previous example of a freelance platform, maybe when a client goes to attest that the project has been completed successfully, they can then transfer some Ethereum along that attestation to the freelancer. In another example, we have a token resolver here that expects a specific amount of tokens that have been approved for an attestation. So you'll be sending ERC20 tokens to the contract itself, which the owner can then access. So as you can see on the test function here, we're going to save transfer from the attester to the actual address of the contract with a specific amount. The one that we will look at today is the Attester Resolver.sol, which literally just assigns a specific attester who can make attestations against a schema. And we're going to use the previous example of having a freelance platform where only the client can attest to your reputation and nobody else. Let's click on this link to the Attester Resolver.sol, and then we can copy this code and head over to the Remix IDE, Remix or whatever. Click on the first link. Once you're on Remix, click on Contracts and create a new file. Let's call it resolver.sol. Paste this in, click OK. Now let's head over to the repo, and we want to import two files here. So we want the schema, we want the ies.sol. So you copy the URL and you paste it in here. And we want the schema resolver.sol as well, which will be in resolver and schema resolver. Copy this, head back over, and now we're going to import in the exact same way. And don't forget to add the semicolon to the end of each line, because this is a Solidity contract. So if you see this error, that means you need to just upgrade the version. So let's do a above any version up 0.8.2. Great. So once it's been compiled, let's head over to this tab here, deploy and run transactions, and then we're going to want to change the environment to injected provider MetaMask. So right now I'm on Sepolia. Now in the constructor, it's expecting an EAS address of type IEAS and an address that we're going to assign to the target attester. We're going to just mock the second one for now, but the first one you can find by heading over to the GitHub repo again for EAS contracts and scroll down and click on the readme.md. Perfect. Now if you scroll down again, you'll see a list of contract addresses, one for the EAS and one for the schema registry for each blockchain that is supported by EAS. Now the one we care about is Sepolia. So you can just Control F Sepolia. Perfect. And we want the EAS address, not the schema registry. So we can just right click, copy, head back in our IDE, we can paste in the address, then a comma, space, and then we want a target attester. So I'm gonna take, yeah. So first of all, I'm gonna connect my Web3 wallet, my MetaMask wallet. So now we're connected, and I'm gonna take this one, Web3 made, go to the end, and paste that in. Now let's hit deploy. Oh, that's better. So now we can clearly see what the constructed parameters are. The first one is the EAS contract from here, and the second one is my own wallet address that I just copy and pasted in here. Okay, so now we can click on my MetaMask. Let's hit confirm. Perfect. So once it's been deployed, you'll see this in the terminal. Now head over to your deploy contracts down here, and we can actually create an attestation, but we don't want to mess with this right now directly. What we want to do is take the contract address, so we can copy this, head over to the EAS Sepolia scan, perfect, and then click on the first link, and then we're going to make a schema. So first of all, we want to connect, okay, my wallet's connected, let's click on schemas, let's create a new one, let's just go with the same one as before. So very basic schema for somebody's reputation as a freelancer. The first one, we're going to have the client name. This is going to be a string. The second one's going to be the value of work, which will be a uint8, so any value between 0 and 255. The next one's going to be recommend, so would you recommend freelancer again? Boolean, yes or no. And now in the resolver address field, so we paste in this value that we've just got from Remix off our resolver contract into here, and let's create schema. Perfect, then hit confirm. Okay, so we've just registered our schema. Now if we make an attestation, let me just put in some random address. So now I'm going to attest to this account here. Let's call them freelancer. Oh no, this is me attesting in the dream. And then I'm going to say 100 for this person. True, on chain, make attestation. Then hit confirm. So let's click on the schema. Sometimes it hangs for a bit. So, okay, there we go. Perfect. So now we've made the attestation against this schema. If we head back over to the schema again, we can see there's been one on chain. If I switch addresses now to this client, let's connect it. Any other address should not be able to make an attestation. So let's attest. So let's paste in the same recipient. So that will be with this one. It doesn't matter in this scenario. Client name, the value of work, 5. So this is somebody who hates this freelancer and is trying to ruin their reputation on chain, make attestation. And we can see that nothing happened there. So if we open up our console, so Shift Command C, transaction reverted. So we could have added in a custom message here, which I actually wanted to do, but I forgot. But it could say, if you are not, if this is false, then say invalid attester. to let the UI know that you are not the whitelisted attester for this contract. That means that on this schema here, only that specific address can make this attestation. Now, this could be a array of addresses, not just one. That would be a lot more useful, but maybe you have a admin account that can only make those claims against your reputation. Let me know if you're struggling or have any questions about resolvers, and I'll help you as best as I can. We've seen just how powerful they can be and how they actually give real world utility to EAS. But we could have many different resolvers associated to one schema. So the possibilities are endless, and I can't wait to see what people do with this. Thank you for watching, and I'll see you guys soon.